So when we want to know the number of carbons present, part of the name is going to tell us that. Meth is 1 carbon, eth is 2 carbons, prop is 3 carbons, but is 4 carbons, pent is 5 carbons, hex is 6 carbons, hept is 7 carbons, oct is 8 carbons, non is 9 carbons, and finally dec is 10 carbons. Now, it's important you learn this. Otherwise, when you're told a chemical name, you're not going to be able to work out what the structure looks like, and that's really, really important. So get used to this numbering system. Okay, so we've seen a number of alkanes now, but sometimes the alkanes don't exist in isolation and they're just part of another larger molecule. How's that happening? Well, imagine losing one of those hydrogens and the bond is now connecting to the rest of the molecule. But this isn't called an alkane anymore. We call it an alkyl group. So instead of ANE at the end of the name, we have YL. Let's look at some examples of this. Well, here is an alkyl that has 1 carbon. You can see the difference between this and its alkane relative is that we have lost one of the hydrogens. And that wiggly line shows this is the part that's connected to the rest of the molecule. So you can see in 3D and in simplified skeleton form. Another way of expressing this is the letters Me. This is an abbreviation for the alkyl group that has 1 carbon. It also is CH3 in its condensed form. So notice there that it's not CH4, we've lost a hydrogen, so it's now CH3. But what are we going to call this? Well, we're still going to use our numbering nomenclature. So meth means 1. So instead of methane, we now have a methyl group. Okay, next one. Let's add another carbon. What we have here, as you can see, is the 3D arrangement and the simplified skeletal form. But there's another letter code for this sort of alkyl group. We use ET to depict a 2-carbon alkyl group. When we look at its condensed form, again, we've lost a hydrogen when compared to its parent alkane. So instead of having C2H6 that we had with the alkane, we now have C2H5 or CH3CH2 instead of CH3. What do we call it? Again, we resort to our numbering system. So it's 2 carbons. This will be eth, but it's not ethane, it's ethyl. Continuing on, let's talk about the 3-carbon unit. Here it is. And we can abbreviate this in a 2-letter form to PR. Now you'll notice here there is a superscript N in italics. Now this is a special code. It stands for normal, and normal means an ordinary zigzag. When you get to PR, or a 3-carbon unit, there are now a variety of ways you can connect 3 carbons together, and the normal form is one of them. Normal, again, is the zigzag form, as you see here. When we look at the molecular formula and the condensed form, again, the difference between the original alkane and now our alkyl is that we have lost one of the hydrogens. What do we name it? Prop will tell us 3 carbons. It's yl, so we have propyl. And finally, let's just talk about the 4-carbon unit. Here it is, and the new 2-letter descriptor is Bu. Again, we have a superscript N to show it's the normal form. There are a number of forms with which we can have the 4-carbon unit assembled in, but this is the normal form, just the ordinary plain zigzag vanilla, if you will, format. With the molecular formula and the condensed form, you can see we have lost one of the hydrogens from the alkane. And what do we call it? But would tell us that there are 4 carbons, so it's an alkyl. We have here butyl.